No one there. Okay. So welcome everyone to the second event of the Smart Immigration to the Future, a part of the Immigration to the Future event. And we now have a lecture slash wine tasting by Kolya, who is Nikolai, who is Ph.D. student at the University of Bremen, and I guess you will tell a little bit about yourself, or
maybe you.
Yeah. So who is a geochemist, but also a wine expert. So with no further ado, please join Kolya.
Well, yes, Denis already told. I'm currently finishing my PhD in the field of mathematical modeling of mineral growth and dissolution, applied to some environmental tasks. And actually, I like a good wine. I think all of you like a good wine. And then I thought, like, maybe I can prepare a lecture about the geosciences in your glass, about all the geological related factors which influence the taste which you have in your glasses right now. A part of this lecture will also give Aglaia. She's here. She is a molecular biologist and computational biologist, and very cool, popular lecturer, by the way. Yes. Well, thank you everyone for coming, and I think we can start. Well, the first question, who started, can we maybe make it darker? Who started to drink first? Actually, the earliest archaeological evidences of wine drinking are from like roughly 9,000 years ago, from Anno Domini, and it's like Turkey, it's China, it's Armenia and Iran. Actually, the whole culture of winemaking, of wine producing, of wine consuming belongs to Armenia. It's about 6,000 years ago. But actually, I think the first hominids, then they just sold these nice ripened berries with a bit fermented alcohol. They tried it and thought, okay, that's nice. That's really nice, let's drink it. So actually, I think wine belongs to our culture since the occurrence of the humankind, of our biological species. Well, let's now try to drink a wine. And here are presented some flavors. I will speak about them later. I will speak about some factors which influence the flavor of the wine. We need to understand which flavors are used by professional sommelier, and you can drink and try to identify them. First, it's aromatics. It's like primary aromas from the variety. It's like fruity, flower, herbs. Actually, I don't know what description of Grauburgunder, but you can try to drink now and or like smell them. Sweetness is very simple. It's what we all use too. It's dry, off-dry, semi-sweet, and sweet. Acidity, it makes the wine sharp. The more acidic or like sour wines are more sharp in their taste. Tannins, it's a special biological organic tannins. It's organic compounds which are forming like the feeling of astringency structure. They're also responsible for aging potential, and they give some texture of the wine. Alcohol, it's alcohol. A very interesting feature of wine is body. It's like something in between, it's like density of the wine. Sometimes you drink wine and you feel like it's very easy, it's like soft, it's like, I think it's like our Grauburgunder. Sometimes you drink wine and it's like a bit heavy, it has like this like heavy body, how the professionals say. Of course, balance, it's how all the wine parameters are balanced and correspond to the total feel, total flavor of the wine, and finish, like short if you don't drink. Yes, it's short. Maybe medium, and long and very long. And of course, aging of the wine. So some wines are young, some wines are aged. That's all of that I think you already know. Well, how does our taste perception works? So the human tongue has 4 types of the papillae on our tongue. So the filiform papillae do not correspond to taste anyway. They are like, actually not biologists, I'm not very into their function, and some of the functions of them are still not well understood. Fungiform papillae contain from 3 to 5 receptors, and they are responsible for the taste. And circumulative phallic papillae contain about 100 receptors. And what's very interesting, we have receptors, of course, not only in the tongue, also in the nose, in the stomach, in a gastroscopical, in our gastro tract. And yes, they also give the signals to our brains about the compounds which we consume. And of course, with the taste which we can distinguish the best is a bitter one, because it gives us the signal that the food may be poison. Maybe. So it's the taste which we can taste the best. Now let's move to geosciences. So in wine and agricultural production there is such term as terroir. It's from the French and from Latin terra, which means land, and it's a term which describes a place and all of the factors which influence the product which you make, and these features can be somehow controlled. So the terroir product is made from raw material grown in specific place under specific controlled conditions, not always controlled. We'll talk a bit later. You cannot control all the things. And beyond the wine, this term is also applied to coffee, tea, olive oil, meat, and so on. So how do you think, which factors are the terroir factors? What controls? For example, which factors control the final product, for example, this wine?
Weather?
Yes.
Obviously the wines from the south of France or from Italy are a lot drier. Wines from the north, like wines from Germany are sweeter.
Yeah. What else?
And then the soil.
Yes, sure.
Water content?
Yes.
What kind of water is available? Yeah, that's a good point. Are you looking for a specific answer?
No. You can.
No, I think it's like we could say.
It's about imagination, not anything. There are things
that's
which do not significantly contribute to the terroir.
Manure? Manure?
Manure, fertilizer.
Fertilizer.
Yes. So actually, you already call some influences: temperature, like climate factors, humidity, winds, like wind growth, amount of sunlight, amount of precipitation, like how much water is there, local hydrology, other rivers, lakes, some small water sources, geology. I will also talk about soil characteristic, topography, and local flora and fauna. So the animals also affect this, like from the bacteria to like the, I don't know, like pools and so on.
Are we talking about like what kind of bees pollinate their?
Yes.
grapes?
Actually, all the animals somehow influence the terroir,
All of the animals. Okay.
which are presented
Okay.
on this area, in this area. So let's speak about first the most obvious temperature. As you know, the wine grapes do not grow in very hot climate, in very dry climate, and they don't grow in the Arctics. So the temperature which is nice for the wine grapes is like Mediterranean region. It's some specific regions with the temperature regime, and actually to understand where you can grow the grapes, you can use several indices. The first one is the number of degree days. It's like the heat accumulated by the soil, and which can contribute to the time where the berry is ripened. is calculated like by the number of days where at a certain temperature. The second factor is the Hagelin index, is the heat potential of the region, how much heat is accumulated from the April 1st to September 13 in the northern hemisphere, or otherwise from the October till March in the southern hemisphere. So the comfortable temperature for the vine growth is roughly 20 to 30 degrees. So if the temperature will be lower than 10 degrees, like will be completely no growth. If the temperature will be too high, like more than 30 degrees, then there will be the problems with photosynthesis, and the bushes like the berries will also not grow. And everything in between is okay. So in comparison to other agricultures, grapes, like wine, is relatively resistant to the temperature, and it can grow from the Washington to the South Africa. Water availability. So yes, the grapes do not grow in a rainfall climate. They don't grow in the deserts, and water access should be limited enough so that all the growth don't go to the leaves and go to the berries. On the other hand, the moderate deficit of the water helps the plant to go more into the berries, not into the leaves. And of course, well-drained soil is a good thing, because there you have a migration of water, and it's more balanced by in terms of water availability. So the roots can get enough water, and the producers, the winemakers, can produce more higher quality wines. Climate. So here is a nice table. So in different kinds of climates, you will get different flavors. Because we'll talk a bit later about that. Because different temperature regimes, different humidity, they differently affect the fermentation and organic and chemical processes in a plant, and it gives a different flavor. So I will not consider all of these factors, you can just read them. So some different climate settings provide different results. So if you want a specific wine, maybe you can think about buy it in Italy, or from South Africa, or from Australia, because the climate difference, of course, will affect it. Terroir. Well, it's not obvious, but geological history of the region plays an important role in wine production. Of course, first wine. All of the soil you have on the earth is produced from the rocks and biological material made by animals. In geology, such term as weathering is destruction of the rocks by some factors. There are several of them. It's temperature. So if you heat up and cool down the rock, it will have higher strain and destroy in time. Then, of course, water. If you have some pores in your rock and the water freezes in them, or it transforms them, or of course it can just dissolve them. It's also weathering. You have mechanical weathering by the roots of the plants, by the animals. You have chemical weathering by the chemical reactions on the surface of minerals. So oxidation, reduction, the main things, some corrosion. And additionally to the vineyards, significant response to the tectonic history of the region. For example, in Burgundy, I don't think you see it here very nice, but you have a fault. It's a place where two pieces, like two big pieces of region, can move upwards or horizontally. And due to presence of the faults, in Burgundy province, there are places with the soil of the first type, and for example of the second. And on one soils perfectly grows, for example, Sauvignon Blanc, and on the second some other type of wine. And also one question to you. There is also an effect of the old glacial periods on the modern vineyards. Which one? How is related the glaciers, like the huge masses of ice, to the modern wine?
Because the glaciers pushed rocks. They pushed a bit. I mean, like sometimes you find like giant rocks that were pushed down by the glacier during the ice age.
Close.
They look valleys? They look valleys? Like glacier make like valleys? Like
No. Actually, the first answer was almost correct. They bring not the big stones, but also the smaller stones, which form the specific rocks with a high drainage capacity. So they provide the drainage for the vineyards. So, for example, the whole Washington province wine, where the US wine is produced, is based on glacial rocks. So, yeah.
In Washington State?
Yes, in Washington State. Yes,
You're talking
they
about
provide they go wine grade there.
You're talking about Walla Walla.
Hmm?
You're talking about Walla Walla
Mhm.
and the Palouse around Walla. That's right.
No, I mean the glaciers, not the modern one.
Yeah, but that's
But those which came from the in Europe, is they came from the Baltic Shield, or what did you mean?
I no, you're referencing a piece of Washington State where I went to college.
Oh, okay.
Walla Walla got really famous for wine in late '90s, and a French guy showed up, and he started one vineyard, and then a bunch of other vineyards popped up, and suddenly there were people making a lot of money.
Nice. It's all thanks to the glaciers.
Yeah.
Yay! Well, the soil characteristics. The one thing, the soil is important, but that doesn't mean that a good wine can be produced on the specific soils. For example, the gravelly soils from the quarter river deposits is Bordeaux, and clay-rich soils from Jurassic limestones is Burgundy wine. And soils can be studied from a way different points of view. Like geologists, like me, usually study the parent rocks, like what is under the soil, and from what soil is formed. Geomorphologists are focused mostly on the topology, because the slopes, the rivers, they also correspond. They also contribute to the soil characteristics and which soils will form. Soil scientists is usually soil mapping and physical chemistry of the soil, the temperature, something like this. Agronomists also study physical and chemical properties, but related to the growth of specific plants. And soil microbiologists, they do some, of course, microbiological study of some microbiological communities. Yes, obvious, guys. Effects of the soil temperatures. One very important characteristic is the soil temperature in the root zone of the plant. And it depends on the soil albedo, basically its color. If the soil is darker, it will get more solar radiation and get more temperature. If the soil is lighter, then of course it will reflect more light back into the space. And of course on the temperature in the root zone is affected by the slope angle. Like if you will have your roots on some kind of this angle, they have different distribution of the temperature in the root zone. And the water content, like water is a very cool accumulator of heat. Actually grapes which grow under warm conditions then usually contain more alcohol, because by the high temperatures they produce more sugar, which then is fermented into alcohol. And if the grapes are ripened too early, then they produce more acids, more organic acids, and then they get sour. So the German wines are usually have a very short period then they grow. but the vine species are very contain a lot of sugar. That's why Riesling is so nice. It's like it's growing in a cold climate, but the species also the time of the growing of the berry is enough to accumulate enough heat to produce enough sugar to be not so sour and enough sweet. And in cold climate, the early ripening is preferred, and in a warm climate, the late ripening. The myth of wine minerality. Have you ever heard about minerality of the wine? Yes? Yes.
I mean, like the term, yeah. But
The term, yes. What does it mean?
I have no clue.
Usually, actually, I saw one guy who like made like this and said, "Okay, I taste these nice limestones," and I was like, "What?" There is a popular idea that the minerals, like full minerals from the soil, can go from the root zone, like from the root, and go into the plant, then into the berry, and then into the wine, and give this taste of minerality. It's actually not very true. First, let's distinguish what is a mineral. Up to you. What do you mean? Like how we can describe what is a mineral?
A rock. A rock.
Rock usually means several minerals which are combined, or several types of minerals. There are also monomineralic rocks, but if we speak about one mineral, can I borrow your quartz? Yes. Oh, sorry. So yeah, here we have a mineral. How could we describe it?
Crystalline?
It's usually crystalline phase, which has a constant chemical composition and a crystal structure. So actually there are organic minerals, but there are only a few of them. And minerals are in 99% of cases inorganic compounds. Yeah, thank you. And how could the mineral go into the root and then to the vine? It's almost impossible. Technically,
Aren't there some minerals that are essential for life? Like
minerals?
Yeah, like
Of
zinc,
course.
like zinc or stuff like that. And we need it to live.
Yes, but there is also a different, like in all this beauty industry and pharmacy, mineral is called usually the elements, like the elements and elemental, like how to say, some usually organic compositions which you take and get more health, like vitamins, zinc, iron, magnesium.
Yeah.
Geosciences don't call these minerals.
Oh,
It's the it's a term which came from geology and geosciences, but in pharmacological industry and beauty industry, it's usually like not you don't eat limestones.
No.
Yes. So in
I
this
just
case,
like maybe you know.
yes, maybe no. I also don't. No, actually, when we started, we had a test when we were taught to distinguish the amount of clay by licking the mineral
Okay.
or licking the rock. So yeah, geologists sometimes can do that, and you can really distinguish it. But the minerals which you can find in Rossmann are not the minerals from the geosciences.
Okay.
In Rossmann there are like some chemical compounds which contain this iron, but that's not minerals in scientific point of view. It's just like for marketing.
Okay.
Well, go ahead.
Does anybody want?
We have more.
Oh, okay.
We have way more.
Plenty more.
So technically, if you have soil, and in the soil are some minerals, they can dissolve. And then they are presented in the form of aqueous species, then you have the iron surrounded by the molecules of water. Technically, this kind of elements, in this case, they can be absorbed by the roots, but it's already not minerals. It's aqueous solution of the ions in water. It's already dissolved. And of course, roots, they absorb the organic compounds which contain inorganic, which contain iron, magnesium, potassium, and I'll talk about this next slide. And what do people usually understand under this minerality? There is a bit of mineral aroma, which is possibly associated with such as organic compound as benzyl mercaptan. Yes, that's what people think is minerality. No, it's organics. Well, but yes, I already spoke about that. Some elements are absorbed in a plant to the plant from the soil, and nitrogen plays a very important role in protein forming of the plant. Phosphorus is a part of some organic acids, and it's also very important also in proteins. Potassium is very important for nutrition. Iron is used to synthesize DNA and RNA in the cells and controls the cell division. Manganese also affects RNA and DNA. Calcium is used for the cell walls. Aluminum is present in cell tissue, in the tissues of the plant and intercellular solution. And magnesium is needed to chlorophyll formation. Well, I think you heard about nitrogen fertilizers for the plants, and it's very important. It controls the growth of the plant, the synthesis of the proteins. I already told that, and most of the nitrogen in the soil is presented in form of organic compounds, and it's absorbed into the roots by help of the bacterial cultures. And they do reduction of nitrogen oxide to some organic nitrogen compounds. And actually, usually winemakers, they're very worried about they care a lot about the nitrogen content in the soils, and they can control that. You can also control it by the natural fertilizers or by the fertilizers which you obtain from the rocks. So a lot of nitrogen is mined out of the apatite and of phosphorite, which contain both phosphorus and nitrogen, and they are then used in our fields. Aglaia, I think it's your turn.
Yeah. So I would implement a little bit about biology back in wine, because I'm working mostly with bacteria, but with the wine we're using yeasts, which are tiny mushrooms, which are like, we call them mushrooms, but they are officially from another kingdom. It's a long story, it's too long. Like basically, like in 17th century we've been believing that we have kingdoms like animals, plants, and minerals. Now we decided that minerals are not alive. Sorry, Kolya, for this sad news for you. But now in basic school we say like, okay, we have bacteria, we have animals, we have shrooms, fungi, and we have plants. But actually nowadays there was like 17 kingdoms.
17.
17 kingdoms, yes. In official, Kolya, can I also have a glass of wine? Like 17 kingdoms. That's not a big deal right now. What is important that sometimes taste of wine is made not because of terroir, but because of organisms we ask to give us some ethanol, which we highly absorb. Well, mostly I heard many things that this specific species of yeasts are not terroir exactly, but we have a variety of strains which can act differently. Because, for example, Kolya a couple of times mentioned that we have like wines from the northern regions which are usually have more fruity, tropical taste, etc. And that's for me sounds weird, because like we are in the north, why the wine tastes fruity? But that's because of specific strain of yeasts which can metabolize sugars to the ethanol on low temperature, like in 10, 12, 16 Celsius degrees. Because other species, other strains cannot do that. So we need to fix ourselves with specific strains and we use them again. And what's interesting, because actually the wine is see-through, so you don't see any small bacteria, microorganisms, so you can clearly see the bottom of the glass. Because, okay, we have the grape, we mash it, we let it ferment, so we give it time for yeasts to produce it, to take sugar and to metabolize it into the ethanol. And after that, we actually don't want to drink all of that tiny organisms. We want to drink wine. And actually, some of those species, they can lysate themselves. So there was a cell, cells are dying, and cells self-destroying itself. So no one was there. But when this happens, we finally see not only ethanol, but we see secondary metabolites. Because the whole this metabolism, which helps those yeasts to survive, and to us as well to survive, sometimes it's not only two molecules or some really easy equation, it's just a gigantic map of variety of molecular compounds which need to be transformed one to another with a variety of enzymes. So when the cell lysates itself, so it's opening the cage, all of those secondary metabolites are coming and they bring in specific taste. I'm sorry, I'm very bad with chemistry names. But this fruity thing, beta-glucosidase and carbon-sulfur lysase, they are super known for Sauvignon Blanc. And that no one can understand what is going on right now. Isoamyl alcohol is a methyl alcohol, secondary phenethyl which gives rosé and honey notes, and some esters such as isoamyl acetate, which smells like banana, or ethyl hexonate, which giving this green apple taste. So different strains have different amount of those secondary metabolites. So that's why they can also give their specific taste into the wine. But what is interesting, how the wine was made before we had all those dried yeast which can bring directly to the juice, etc. We've been using, no one was adding yeast, because about fermentation we knew only by Louis Pasteur in the 19th century, so it's super late. We've just been using yeasts which was growing on a top of berries. But what's interesting, for example, yeasts for bread, for beer and for wine are actually very the same. So the yeast which we can find on rye or the yeast which we can find on grapes, the wild type is the same, but the strains are very specific. So the day we started accidentally domesticating those tiny organisms, we started to shape-shift them into what do we want them to give us as a taste or as an amount of alcohol we can produce.
That was actually going to be a question of mine. How human engineered are grapes?
How human engineered the grapes?
Yeah, we at the very beginning you said we've been making wine for the last 10,000 years or more. You said 9,000 years.
Yes, 9,000, 6,000 the culture.
Well, yeah, but so in that time we've obviously tailored grapes to be what we want them to be, right? Just like corn, right? Wild corn is tiny.
Mm-hmm.
The Native Americans engineered corn to be what it is today, right? And tomatoes, I think, are the same way. Like there are all of these plants that we eat where we've made them that way, right? So like, I don't know what wild grapes looked like before humans started, using them for agriculture. But
I think smaller and
Yeah,
much
yeah.
more acidic.
I bet they were probably like, tomatoes or something like that.
Yeah, it's like with pears, because like if you ever try wild pear, it's impossible to eat because when you're eating like normal pears from the supermarket, you feel this a bit like
Astringency.
Mhm.
yeah, insertions inside that, and that's the protection of pear because the plant want the soft, like juicy part to not be eaten by some animal, but to like become a fertilizer.
Okay.
Yeah.
And wild pears, they have so much of those insertions, so you cannot eat it. It's like it's like eating sand. So no one eats it, but amount of sugar is enough for seeds to then grow up.
Okay.
So that's actually beautiful. But with sharing, for example, proper yeasts for fermentation, we can use must for that. So you can just how must? Susla. Must.
Must.
So like it's. Have you ever saw those videos on Instagram of people making proper dough bread, like with those puffs? When they have like a specific culture of yeast, you can store and then share with each other.
Yeah.
So the same you can do with wine or with beer.
It's called starter. And
Starter?
Yeah. It's mainly used for sourdough. Cooks often refer to it as the bitch.
I was just not sure that I can use starter for wine. Interesting.
But with bread, you have a container that you're.
No, I know what is starter. I didn't know that I can use this word to describe the same for wine. But
I'm not sure if it applies to wine too. Maybe there's a
yeah. But what's funny about beer, which is like, I know we are drinking wine right now, but there was an institution in Israel which found the most ancient amphora, which was used to make beer.
Mhm.
So they scraped the yeasts from the inside part,
Oh shit.
made them alive,
Okay.
took old recipe of how to make beer, and brewed the beer like it was like many centuries ago. And there was like, they have this interview like the whole album like, we did the beer, but now we was a bit afraid who should try it. Is it even tasty? Can we not die? We'll drink it. So we decided to drink all together. And for a while it was possible to buy this beer in an institutional cafeteria.
Okay.
You just go there like, can I please have one beer like 5,000 years ago, please? That was, I would like to try it. But I think they canceled this already. And also meatballs of mammoth. But for this I need to go to Sweden. I'm sorry. Just tasting science.
Okay. I'll go forward. Yeah. I think actually the taste of wine is the interplay of terroir and subbacterial culture. There is no any single factor which affects the final product. And if we speak about the microbial culture, there is like a mycorrhiza, which is a symbiont of the some fungi and root, which helps it to absorb the microelements better. And this is a symbiont. And the different bacterial culture, they can modulate the pH level, like the acidity, the nitrogen levels, the phosphorus levels, and also to modulate the immunity of the plant and production of the cellulose. Like some different families of bacteria can serve for different purposes, and actually it's usually a symbiosis goals. They get something from this plant. They use it for nutrition and stuff like this. Terroir management. Of course, people try to know how to manage the terroir. Which information can we get? And there are several ways how to do that. There is isotopic methods, which I also mentioned. For example, about water availability. So if the amount of 13 carbon isotope in your plant is very high, it means that your plant was growing in a small, in a water deficit. Why like this? Then the plant or any organism is growing, it fractionates isotopes. For example, you inhale the air now. We have the oxygen isotope 16 and 18. 18 is heavier. And it's actually, for now, not very well known why, but the living organisms, they prefer the lighter isotopes, and you fractionate them. So in comparison to the bulk atmosphere, you inhale more oxygen 16 than oxygen 18. And the same can work for the plants for carbon. Of course, the most thing we can do on the Terra is to monitor the water availability, like how much water is there, can we do something like this. We can do something with the soil albedo, with the temperature, and to the fertilizers. So it's the main things which we can control. And also from the 90s, there are methods of the remote sensing of the terroir. First there were airplanes, then satellites, and now the vineyards are using the drones. And for example, can you answer how you think why you should replace the satellite image by the drone image? What's the difference? Like you get maybe the similar images, but why you need to use like this small flying bug which flies over your vineyard?
You can see the leaves. You can see the leaves with the drone.
Technically, yes. This maybe the correct answer because it's partial resolution. With the drone, you can get resolution up to 5 centimeters. And for remote sensing of the terroir, I used different methods. It's like optical spectroscopy. When you can do it even by the simple camera.
It's probably also cheaper.
It's cheaper. It's the cheapest.
Because you own the drone, I bet, and so it's like a one-time investment, and then you own it. If you're using satellites, you don't own the satellites, so you gotta buy
You don't own the satellites. You get the data, but a lot of data is in open source.
Oh.
So you can get, for example, infrared spectra of your vineyard, and I don't think it's very expensive actually.
Okay.
Because when I was a student, we got some infrared surface spectra of some region, and we calculated how many plants are there, how much of them are growing, stuff like this.
So it's mainly the resolution.
It's mainly resolution, and it's easier.
You get a lot more.
It's easier.
Okay.
So, in case if we do like just pictures in optical diapason, then there are used the wavelengths bands which correspond usually to our normal vision, like red, green, blue. But the camera can also collect the data from other wavelength bands. And if we just make an optical picture, we can see the bushes, the leaves, yes, but other wavelengths, should I explain what the wavelength? No. Or should I explain what the wavelength is?
I think I understand what the
Okay, no, you have like the electromagnetic field, you have the optical diapason, the wavelengths correspond to specific energy of the wave to specific color.
Right, so from red
to purple, and actually there are the wavelengths which are beyond the optical, the optical diapason or electromagnetic waves, and for example, the wavelengths which go beyond the optical diapason can be used to study vegetation and, for example, leaf density. Second thing is the thermal sensing. You just measure the temperature of the surface. It's possible from the satellite, it's possible from the drone, it's possible from the airplane. A very popular method is LIDAR. It's like distance and ranging. It's used to make the very detailed topography. It's just your drone is flying and making short laser pulses which reflect from the surface. and then you get a huge 3D map of the dots, where you can see all of your topography features. And based on that, you can figure out where is better to make the plants, how is water differently floating on your vineyard, and so on. The microwave spectroscopy is used for to understand the physiological state of the plant. Yes.
Up. You literally carry down the.
Yes, you set the microwaves.
And it works.
It works. And the fluorescence is used to get the water content in a grapevine, because it reflects, it goes from the satellite from the drone to the leaf. Leaf absorbs parts of it, and depending on how much of water do you have in there, it reflects the part of this wave. So here's, for example, I don't know if you see it very, no, you don't see it very nice. Here is the simple picture, which is sampled by the dots. And afterwards, after processing of this data, you can get the map of different regions, of different vegetation, of different sunlight consumption. So it's very useful, but actually it's mostly working for a big wine production, well, for producers, because they can afford this. Here's also a very nice example. For example, it's a method which is called normalized difference vegetation index. It shows how your vineyard, how much of the water do your wine grapes get. And it gets the raw image, then it processes it and shows the places where your canopies are situated. Then some processing, and you can get first the size of the bushes, second the ripeness. You can go with the drone and check if the berries on your vineyard are already ripened.
Jesus fucking Christ.
Yes. Yes.
Okay.
And then you can just like collect them or sample, and usually the sampling is done over these lines where the canopies grow. And usually in the line the canopies are almost there's the sorry.
Have some more wine.
Yes.
It's well known. I think like 6 ounces, 5 ounces maybe of wine will help you with language.
Yes.
And anything more than that, and you're fucked.
Yes. And a little bit more. Actually, there was a Nobel Premium. Then the scientists proved that a little amount of alcohol helped to speak a foreign language. Yeah. It's scientifically proven fact. It's nothing that we told now. Yeah. So, of course, then you grow your berries. You need to select them. Here are different kinds of different arts of wine and the temperatures that they grow. So depending, I hope you can see something.
It's so blurry, but yeah,
I can actually turn around my laptop.
It's okay.
So for example, Riesling is here.
I get the idea.
Ah.
I see Chardonnay, I see
Pinot Noir, I see Chardonnay, Sauvignon Blanc.
So it's different temperature diapasons. Where the
Cabernet Franc, Paradis,
Viognier,
Dolcetto, Noir,
Syrah.
okay,
Okay, go ahead.
Yeah. That's actually the most important. You can see the different kinds of the wine grapes grown in the different types of climate and by different temperatures. And based on the terroir factors, maybe also on the soil microbial cultures, you need to choose the wine which you need to grow. The wine grape calls Riesling will not grow in South Africa. And I don't. And Zinnfadel will not grow in Germany. So you need to be careful. This is also a very interesting kind of wine. You all know it is ice wine, which is not collected before the winter comes, and it's self-fermented in a sheet of ice. Very nice thing. What determines the flavor? I need more wine. Of course, it's the terroir effect. It's sugar content in the grapes, which controls the alcohol level. And now this bottle controls alcohol level in my blood.
No, I was not okay with that. Amazing.
Organic acids and some other organic compounds which are responsible for what you taste. Chemical analysis of wine. Usually people do the chemical analysis of wine by two ways. It's mass spectroscopy. It's like this size box where you put a small sample. For example, you bring to a bit of wine in it. Then it ionizes all the compounds. Then they go for the magnetic field, which is usually has like the ball shape. And all the ions, all the parts of your sample have different mass and different charge. And based on a relation mass to charge, like ions 2+, 1+, 3+, different masses, like for example potassium or sodium or barium, they have different mass. Or for example barium and magnesium, they have the same charge but a different mass. And they can be the ions with the same, or the compounds with the same mass but a different charge. So the equipment, the analytical equipment measures the relation from charge to mass, and then you get all of your chemical composition of the sample. The second way is chromatography. The simplest example is when you have the piece of paper, then you have dirty water, and then you make several drops of the dirty water on the piece of paper, and then you have the lines. Your system separates into different compounds, for example, dirt and water. The chromatography is based on the distinguishing, like on the differentiation of the different compounds by the transport. So you need the transport media and your compounds. They have different kinetic rates in this media, and then based on it, you can distinguish them. This paper, the guys made the biggest chemical analysis of the wine, and they found there, if I remember correctly, more than 10,000 of different organic compounds. That's more your topic, you're a chemist. Okay, how do you think? What is the main chemical compound of the wine?
Ethanol.
No.
Water.
Yes. Ethanol, water.
Yeah, that makes sense.
A bit of hydrocarbons, and these 2% are other compounds. And from these other compounds, here are some nitrogen-bearing compounds, a bit, some inorganic compounds, these minerals. Of course, there's usually this aqueous solutions which the roots absorb from the soil. Here are some other organic compounds, some from the other, there are also other, and other, and other, and other. Some volatile compounds, lipids, terpenoids, phenols, and acids. Now I'm going not to actually my land because I'm more inorganic chemist. And here are mostly organics, but I'll try to explain. Well, wine flavor compounds. For example, the phenols, they are divided in non-flavonoid and flavonoids. And they cause the bitter taste of the wine. And anthocyanins, they are coloring the wine and determine and they're tasteless. Proto-anthocyanins, they are usually in a skins and sweet, and they correspond to the bitterness also, and to astringency, like this feel on your tongue. And tannins from the compounds from the seeds, they contribute to the bitterness and to also to astringency. So here you see the berry, and while the berry is growing, it accumulates different amounts of organic compounds, and then the berry is small. Then first it accumulates proanthocyanins. It's bitter, it's acidic, it's not tasty, and the berry is green. Afterwards it goes with time, then it starts to accumulate anthocyanins. They color the berry, and also the berry starts to contain some sugar. At this point is called like the sugar point after which the berry starts to get sweeter. And afterwards, at the end of the growing, it gets aromatic compounds. So that's why the wines which are grown in a cold climate, which have not so much time to grow, they don't have so high aromatics. And the wines the grapes which are grown in a warm climate, they are like more aromatic, they have more sense of aroma. Yes, these aromatic compounds, there are hundreds, thousands of them, and we can feel them if they're presented even in concentrations 10 in power minus 4 to 10 power 12 gram per liter. Oh no, it's just a concentration, I'm sorry. But we can also sense them. We can sense them. Different compounds produce different aromas. So complicated words, I'm sorry. Methylhydropyrazines, they produce green bell pepper aroma. Terpenes, they are responsible for citrus and herbal aromas. Carotenoids are responsible for tropical aromas. Volatile phenols, they give smoky and spicy aromas. And thiols, you can feel something like from grassy to pineapple. And then several questions like, okay, you got a bottle of wine. Here is written Sauvignon Blanc. Qualitätswein token. Okay, we can assume it's from Germany. How we can prove it? To prove it, we can use isotopes. As I already told you about oxygen, which you inhale, and the carbon, which shows the water deficit or availability of the plant, we can use the same technique for determination of the region of wine production. Each part of the world has, how to say, its own, each vineyard has its own isotope composition. So isotopes are the atoms with the same number of protons but different number of neutrons. So it's the same element, but it has different weight.
Is this true for any agricultural product?
For which?
Any as you're saying wine has basically an isotopic fingerprint that indicates where it came from. But
yes.
Wouldn't that be true for like anything? Like
any production?
Apples? Yeah. Apples.
Yes, of course. Yes. You can distinguish juices. Yes. You can. Actually, first it was developed for rocks. For leather. For example, you need to get the information. Did this rock form in mantle or in some magmatic from some magmatic source or from hydrothermal? Like the isotope ratios were developed like by geologists and also by organic chemists. Like geologists usually get a lot of information, like where did the rock came from, how was it formed, with the age of it. Maybe Paul, you can add something to this.
I only know that it's also commonly used to like identify the origin of honey.
Origin of honey, yes.
Honey is also
rocks.
like try to obscure like where it comes from because it's cheaper at other places. So
Yes. You can use it for cheese, for anything. You can even use it for this table.
For cheese.
For cheese.
For cheese, of course, yeah.
Yeah.
This is fermented product, but it's also like what the cow or the goat or the other animal eats at this very season. Also kind of make this mapping
Mm-hmm. And
possible.
was this cool from India or for European Union?
Yeah.
That's fucking cool.
True.
Okay, usually for, I will just, I put it here a formal because I will use it further. It's called delta, some isotope. For example, delta deuterium, the hydrogen with one neutron. You measure its concentration in a sample, its concentration in some standard. Then minus 1, multiply 1000. It's actually not very important, but this delta indicates the deviation of your isotopic composition from the isotopic composition of the standard. And for each wine, for each region, deltas of the carbon isotopes, of nitrogen isotopes, of oxygen isotopes, or hydrogen isotopes will differ. What can we learn from the isotopes? For example, from the oxygen we can get climate, temperature, latitude, and precipitation, evaporation in a region. From deuterium in water, it's very nice climate marker. Like high values of the deuterium means that your wine was growing in a warm climate. Low values that in a cold. Then carbon-13 in ethanol shows you, did somebody add some alcohol to your wine? or it was fermented naturally.
Okay.
So it's like carbon-13 is a sensor of the added non-natural alcohol.
Right. Okay.
And nitrogen, of course, is a marker of the fertilizers. Were the fertilizers organic or inorganic? Strontium is like geological thing. It's the marker of age and the type of the rocks. On the strontium isotopes is based one of the method of rocks dating, which is called rubidium strontium. Because you have the radioactive isotopes which decay, and they produce the daughter isotopes. And for example, strontium is formed from the rubidium. And then by the relation of the different isotopes of strontium, you can calculate like how much of rubidium decayed, and then you get the amount of strontium decayed about one isotope of strontium, and you can assume which age has your rock and which age had the rocks where your wine was growing. And the lead, of course, the anthropogenic factor. The lead is in benzene, and you can get what's your 1 year close to the huge chaussee with the cars and tracks, or it was growing in bio-natural, supernatural conditions. Bio. Now the isotopic question to you. I think you know it, so please stay silent. Yes. There is an isotope, carbon-14, which forms in the atmosphere through the interaction with the cosmic radiation. Actually, from the 1950s, its concentration significantly grew and then came down. The first question, what the hell happened?
Are we talking about acid rain now?
What?
Acid rain.
No. This isotope is formed in atmosphere.
Okay.
It's formed in atmosphere, the interaction of the
It's more
cosmic
about
rays.
atmospheric holes. Yeah.
It's more about what?
Atmospheric holes that UV. I don't know. I'm just.
Is it the ozone problem?
What?
No. it's not the ozone? Okay. But I mean, acid rain is a huge problem, and then right around that time period, we solved it, and then now it's not an issue anymore. But then it's okay.
Review it.
If you want, like actually the normal level is like this.
So this is
It's
something
a hint.
human generated.
something happened. What?
Where does it hit its peak? 1960?
1965, something like this.
Yeah.
Hiroshima was before.
Yeah, Hiroshima was 1945.
Exactly. 20 years before.
And I mean, after Hiroshima, I mean, America, everybody was going crazy with nuke testing.
That stands for.
Oh, is that right? Is that right?
It stands for yes. That whole anomaly, which is in on the scale of the whole Earth, like on all Earth, even already in the rocks everywhere, is the anomaly of carbon-14, which was formed by the nuclear weapon, like all this stuff.
Yeah, like Bikini Atoll.
Yes.
Totally.
Second question: how is it related to wine?
You can get the age of the wine.
Yes, correct. Chemist, you can get the age of the wine because if your wine was produced before 55, then in this wine you will not have the anomaly of carbon-14. Or you can just track the year of your wine production. So imagine like somebody brought you a Sauvignon Blanc and says it's from 19th century. You make analysis, it's here. No. Okay, looks like it's the time for me to wrap up. Drink a good wine, enjoy life. This lecture was more or less supported by the cheapest wine from my phone at the supermarket.
I remember the box.
It was the cheapest one.
Yeah.
50 cents per liter.
Cabernet, is that what
It's Cabernet, yes, it's Cabernet.
Totally idyllic.
Yeah.
Okay.
Peat? Or,
Yes, if you want to read it.
No, I about a month ago I taught myself kind of how to read Cyrillic, and so I'm, yeah, it's interesting. I still don't know how to pronounce it very well, and I've never the little marker that says this is supposed to be quieter than or has a different tonal quality than without it. I have no idea how that fucking works, and I can't hear the difference. It's like, no. Instead of t, it's t. I'm like, I hear nothing.
Okay, this acknowledgements. Thanks to Dr. Ina Kruganska and Dr. Daria Bronska for critical suggestions and comments to the lecture. Of course, thank you for Aglaia, who gave her words for Red Bull a bit, and of course for all of you, my patient listeners, my patient audience. Here are some references.
Salute.
Thank you.
Salute.